Hello, welcome to our lesson. In today's lesson, we want to learn how to derive the compound angle identity. So the compound angle identities. So the first compound angle identity that we want to learn how to derive is the identity of cos. So we want to learn the one for cos alpha minus beta is equal to cos alpha cos beta plus sine alpha sine beta. So this is the compound angle identity that we want to learn how to derive. And it might interest us also to note that once we are able to derive this identity, it means the other three that remain, which are cos alpha plus beta and sine alpha plus beta and sine alpha minus beta, we can also be able to derive them from this very one. So it's very, very important that we are able to derive this one, as it is the one that plays the key role in deriving the other three that remains for compound angle identity, right? So what we have here is a Cartesian plane. So this is the x-axis and this is the y-axis. These are the two axes we are having on our Cartesian plane. So we shall label this one 1 unit and this one 1 unit, meaning to say the length from O to A and from O to B are actually equal. Then we are going to call this angle here angle alpha. We shall also call this angle here angle beta, right? So we have our two angles. So definitely the angle that lies in the other triangle that has been formed, or AB, it means it's going to be alpha minus beta. So we have our two angles together with this one that has been formed between them. So it's going to be alpha minus beta. So we want to use that triangle OAB to derive this identity that is below. So the first key thing that we do is we use the cosine rule. So we shall use the cosine rule to derive it. Cosine rule says a squared is actually equal to b squared plus c squared minus 2bc cos a. So in this case, we are going to say ab squared is definitely going to be equal to 1 squared, the other side that we are having there, plus 1 squared minus 2 multiplied by 1 cos what? Alpha minus beta, since it is the angle that lies inside our triangle. So if you look closely, what we are saying is it is our AB indeed. AB squared is going to be equal to 1 squared plus 1 squared minus 2 times 1 cos alpha minus beta. So we have created it. Let's try then to simplify what we are having. So in simplification, we end up having 1 squared plus 1 squared, obviously is going to give us a 2, minus 2 times 1, that's going to be minus 2 cos alpha minus beta. So this is what we have. All right, so this is cos alpha minus beta. So upon simplification, this is the first simplification we have for AB squared in the representation. We have used the cosine rule. So we will call this our first stage in simplifying or in deriving this identity. So the next stage that we are going to have is creating again another equation for AB. Now, this time around, what we are going to do is on our Cartesian plane, right? These 2 points, A and B, We shall label their coordinates. Let's just call this one x1, s2, y1. So we have our 2, it's x1, s2, y1. So this is what we have. Then the other one also we can call it x2, s2, y2. So the first thing that we want to do is we want to represent x1 s to y1 together with x2 s to y2 in terms of cos alpha and cos beta. That's what we want to do, right? So what we are going to do is we will focus on 2 points that we are having there. It might interest us also to note that here, if we pull down up to this point, there is a right angle triangle at this point, right? So this is where our x1 is actually lying. It's here, x1 is here, and definitely y1 is also somewhere here. That's where it is, right? So same applies on the other triangle there. We can say from B going down here. Okay, let me try to use a different, okay? So we are saying at B here, there is another point again. So this is x2. This is where x2 is. So it's interesting that what we are noticing there are 2 right angle triangles, right? So let's start with this first one where we have x1. It means we can say for x1, we can therefore say cos alpha, the angle that lies in that particular triangle, cos alpha, it is equal to adjacent over hypotenuse, that is according to our trigonometric ratios. So it means it's equal to adjacent, and what is going to be our adjacent? X1 over our hypotenuse, which is 1. So we can put that in writing to say cos alpha therefore is equals to x1 over 1, adjacent over hypotenuse. In the same token, we can also create an equation for sine alpha. Sine alpha is also going to be opposite, which is y1, over hypotenuse, which is 1. So hence, an equation can be created for it. It's going to be y1 over 1. Therefore, it automatically means that cos alpha here is equal to x1, and sine alpha here is equal to y1. Therefore, it means x1 s to y1 for the coordinates of A can then be written as cos alpha s to sine alpha. It's possible to say that. Why? Because cos alpha is equal to x1 and sine alpha is equal to y1. Right? We can do the same again for the point B. On point B, we are saying cos beta this time around is equal to adjacent over hypotenuse. So our hypotenuse, remember, it's 1 because it has equal length with OA. So it means that adjacent is x2 over 1. Hence, we can also repeat the same to say cos beta is therefore equal to x2 over 1. Same applied with sine beta. It's also going to be equal to y2 over 1. Therefore, the coordinates, the new coordinates for B can be represented instead of saying x2 s to y2. We can therefore say cos beta s to sine beta, right? So these are the coordinates of B. We have the coordinates of B. We now have the coordinates of A, newly represented. Cos alpha, sine alpha, cos beta, sine beta. Now, using the distance formula, we can therefore calculate the distance of AB using our newly found coordinates. So we are going to say, the distance formula says that D is equal to the square root of x2 minus x1 bracket squared plus y2 minus y1 bracket squared. Okay, so in this case, we are going to say also AB is therefore equal to the square root of, which means this is our x1, y1, remember. This is our x2 and y2 respectively. So it means we can say directly cos alpha minus cos beta bracket squared, right? Plus sine alpha minus sine beta bracket squared, right? We can actually square both sides to eliminate the square root. So we end up having AB squared is equal to cos alpha minus cos beta bracket squared plus sine alpha minus sine beta bracket squared, right? So this is what we have. But however, we can actually expand this cos alpha minus cos beta bracket squared by inspection. So I'm just going to quickly explain here how we can expand quickly by inspection any quadratic perfect square. So we have, like, for example, x minus y bracket squared here. So we are going to expand it directly as x squared minus 2 times x times y plus y squared. So always it's going to end with a positive value here for it to be a perfect square, as it is a perfect square. So we end up having x squared minus 2xy plus y squared. So what if it was a positive here, assuming it was a positive? It means also here it was going to be a positive as well. So you just mark that for a negative, it's going to come out like that. So every other quadratic expression can be expanded by inspection in that way. Okay, so it's exactly what we want to do here. We are going to expand this by inspection. So what is it going to give us? It will give us cos squared A, cos squared alpha, right? Minus 2 times cos alpha times cos beta, right? Plus cos squared beta, right? Plus, we repeat again for the other one. We're going to expand it again by inspection. So what is it going to give us? Sine squared alpha minus 2 times sine alpha times sine beta, right? Plus what? Plus sine squared beta. So this is what we have, right? So we can actually simplify this further to give us cos squared alpha minus 2 cos alpha cos beta, right? Plus cos squared beta, right? Plus sine squared alpha minus 2 sine alpha sine beta, right? Plus sine squared beta. So this is what we have, right? So at this stage, we can then try to simplify what we have by grouping. So we are going to group what we are having right here. So we can start with cos alpha, cos squared alpha, as well as sine squared alpha. So we will take them cos squared alpha plus sine squared alpha. We have grouped them. Plus, we are seeing again cos squared beta. So we take it down, cos squared beta Then we also see sine squared beta. So we also take plus sine squared beta, right? Then we are left with minus 2 cos alpha cos beta and minus 2 sine alpha sine beta. So we are going to group them as well. Minus 2 cos alpha cos beta minus 2 sine alpha sine beta. But however, these two that we are having, this one and this one, they are the square identity. So we know them as square identities. So cos squared alpha plus sine squared alpha is actually equal to 1. Plus, same applies, cos squared beta plus sine squared beta is also going to give us a 1. Minus, so let's take an advantage here that we are seeing. We see a common factor minus 2. So let's just factor it out. So if we factor out the common factor, minus 2 bracket, what do we end up having? We end up having cos alpha, cos beta, plus sine alpha, sine beta, having factored out the common factor, which is minus 2. So this is what we have now, the simplified version, which is going to give us, of course, 1 plus 1, that's a 2, minus 2 cos alpha cos beta plus sine alpha sine beta in bracket, right? So we now have two expressions for AB squared. We have this one, right? We also have another one that we had created before, which is this one. So we now have two of them that are both representing AB squared. So what do we do at this stage? We equate the two. 2 minus 2 cos alpha minus beta. We are going to now therefore equate it to this one. So we will say 2 minus 2 bracket cos alpha minus beta is therefore equal to 2 minus 2 bracket cos alpha cos beta plus sine alpha sine beta, right? So we can now try to simplify. We can transpose this 2 to the other side. So what are we going to be left with? Minus 2 cos alpha minus beta is equal to 2 minus 2 bracket cos, okay, let me try to, okay, 2 minus 2 bracket cos alpha cos beta plus sine alpha sine beta minus 2 that we have transposed, which means 2 minus 2 is going to give us a what? A 0, right? So what are we left with? We are left with minus 2 bracket cos alpha minus beta. This is what we have, right? So here there is a bracket, of course, is equal to minus 2 bracket cos alpha cos beta plus sine alpha sine beta. This is what we have, which means at this stage we can actually divide by minus 2. We can divide by minus 2. So what do we end up having? We end up having negative 2 divided into negative 2, 1, negative 2 divided into negative 2, 1. So we will end up having cos alpha minus beta being equal to cos alpha cos beta plus sine alpha sine beta. So there is our equation. for cos alpha minus beta, which means our identity for cos alpha minus beta is R. So we say this identity is good to know because it is the one that also derives the other three that remains, our compound identities, right? So this is it, guys.